Hi there, welcome back to our amazing journey through the fascinating world of physics.
Today we're going to learn more about the second law of motion by the legendary Sir Isaac Newton. But before we jump into the action, let's have a quick pop quiz.
Do you remember Newton's first law of motion? If you do, give yourself a high five.
Newton's first law says that a body that is at rest will remain at rest, and a body in motion will remain in motion unless an external force acts on it.
But I wonder though, why are some objects really easy to move and others are really hard?
This is where Newton's second law of motion comes into play. Newton's second law states that a force applied on an object is equal to the object's mass multiplied by its acceleration. But what does this equation look like? Let's use our ball again to explain. When we apply a force to the ball, it will accelerate. This time, we'll apply a stronger force. Send it home, Nina. That really accelerated fast. Let's compare the two trials. Since the mass of the ball stayed the same, when we applied a larger force to it, the acceleration increased. Can we figure out how fast it was going? Yes, if we stop to do some calculations. But we've got to keep moving. Just remember that if we apply a stronger force onto the same object, the acceleration will increase as well, according to the equation.
What about the other factor in the equation, mass? What would happen if our force was constant, but the mass changes? ESA astronaut Samantha Christopher Reddy is going to play around with mass on the International Space Station.
Samantha uses a bungee cord to apply force to different objects with varying masses. First, she tries it with a small yellow ball, which has a low mass. When she releases the ball, it zooms up. Next, she tries it with a football, which is heavier than the yellow ball. As expected, the football accelerates much slower than the yellow ball. But what if we go even bigger? Samantha decides to test it out on herself. She's an astronaut after all, and she's got a lot more mass than the other objects. When she releases the bungee cord, she accelerates the least. Why? Because she has more mass than all the other objects. Samantha demonstrates that when a force remains constant, the more mass an object has, the less it will accelerate. From the demonstrations we've seen so far, we can confirm that the force applied on an object is equal to the object's mass times its acceleration. We've also learned that these variables are related to one another.
Force and acceleration are directly related. Mass and acceleration are inversely related. And mass and force are directly related.
That's 2 laws of motion down and 1 more to go. 1 more set of actions.
And reactions.
And we'll be good to go.